Hello guys, we are now going to solve problem count collisions on road. So it is a medium problem of lead code, but let us first understand what the problem is saying. So there are n cars which are numbered from 0 to n minus 1 and everyone is placed at unique point. Now for each car, we have been given a direction which is either left, right or staying at the same position. And all the cars, if it is in motion, it is moving with the same speed. Now what we have to do, we have to count the number of collisions, and based on that, if the cars are in opposite directions and they collide with each other, we get 2 points. But if we collide with a stationary car, we get 1 point. Right now, there is one more thing that when the car collide, then both the car comes to rest. We can assume that both the cars are staying at that same position. So we have to return total score after the collision. So see, it is a pretty simple problem, and it can be solved in O of n. So it is basically, suppose there are cars. It is moving left. Left means in this direction, and it is moving left. All are with the same speed, so it can never collide with each other. And if it is in the right, then it will be moving this direction. It will never collide. So to collide only, and speed is same, so there is no chance of overtaking. So for collision, only one case is when two cars collide. It is only one case is possible. Either it is right or left, and if it is colliding with a staying car, then either it should be at the moving in the right direction from the left side, or it is moving in the left direction from the right side. Only these three conditions are the conditions where we have to check the collision case, and in bottom case, in this case we will get a score of 1 in both the case. Here we will get a score of 2 in both the case. So what I thought is that, see, whenever a right and left car collides, it we can assume that it is staying. It comes to a stay position, right? So what we will do, we will first of all we will find how many RL pairs are there. If any RL pairs are there, it means that that car is going to collide and we are going to get a score of 2. Now when we are getting the collision after eliminating the RL points, the car which are collided, what we are doing, we are assuming that RL car are also standing. Along with that, IS car are also staying, and whichever is the most rightmost point, all the points which are R, which is not a part of RL but which is R behind this, will get collided to this. So for that we add a score of 1. And for the first position, where either it is S or either it is RL, in both the case, whatever case we get first, all the cars which are standing to the right of it and with a left L segment, but L should not be a part of RL, then it is going to collide with it and we are going to get score of 1. So now let us see the code. What we are going to do, we have taken the length of the string, and F is the position of the first, either it is RL or S. In both the case, we will assume that it is going to be a string. And L is the position, is the like is the last position where we are going to stay, right? So what we are doing is that we are iterating over the length 0 to n, and if directions of I is equal to S, and if we have not got our first position, then we are producing in that F is equal to I, and last position we are updating the last position. Now suppose if I is less than n minus 1 and it is position of RL combination, then also collision will occur. So we are increasing our answer by 2, and what we are doing, in the first position we are storing I plus 1, like R and L. If it is R and L, R is position I, so we are going R L means we are storing the position of I plus 1 L. So all the things that are right, that are all the things that are to the right side of this, all the L that are right side of this RL will be our answer. And we are also showing the first position of R as a case of L. Suppose what happens sometimes that S comes and then RL comes, so it is better to take this RL case, because there may be something R in between this. So there may be something, yeah, right, R may be in the between this, which may collide with this, and we get 1 point. So we are also considering RL which is at the last, and RL or S. Now see, if F is equal to minus 1, this means that there has been no RL pair or S. So in that case, whatever we are the answer, we are going to return that After that, suppose if we get something, there is a collision, that means there is a staying car in this. So what we are going to do, from the first position plus one, next to the first position where we have got RL or S, we are starting moving from the F plus 1 to the N. And if directions of I is equal to L and I mentioned is not equal to R, means it is a L but it is not a part of RL, then answer plus is equal to 1. Same we are doing for the last 0 to L, and we are checking if it is a R but it is not the part of RL, then we are increasing our answer by 1, we are returning the answer. So that's it. Thank you. It is a Python